The brake system plays an important role in decelerating, stopping, and parking the automobile. It consists of various components such as the brake pedal, brake booster, master cylinder, proportioning valve, disc brake, drum brake, and the parking brake lever and cable. Brake system maintenance requires utmost attention and accuracy. Oil or grease left on the lining or pad during maintenance causes brakes to pull to one side. Assembling a small part in the opposite direction causes brake fluid leak. Such carelessness may harm the customer or pedestrians. This video will provide information on the outline and operation of the brake system and troubleshooting for problems. To begin with, let's see the components of the foot brake and the operation. The force applied on the brake pedal is converted to a larger force according to the principle of the lever. There is a relationship between force F2 applied to the push rod of the master cylinder and force F1 applied to the brake pedal as shown here. When assuming that distance A is 5 times that of distance B, then force F2 will be 5 times the force of F1. The brake booster increases this force utilizing the atmospheric pressure difference. The need for brake boosters has increased along with the wider use of disc brakes without the self-servo effect. The drum brakes use friction generated by rubbing the drums against the lining to stop the vehicle. Opposite forces are applied to the front and rear shoe. The trailing shoe tries to push against the force, while the leading shoe is pulled into the revolution and produces a larger brake force. The increased braking force is called the self-servo effect. The disc brakes, which press the rotor disc with pads from both sides, do not have this self-servo effect. So a larger power needs to be produced by utilizing the brake booster. We'd like to learn more about the brake booster operating principle. A vacuum is created inside the brake booster by starting the engine. When the brakes are not applied, the pressure of the constant pressure chamber and variable pressure chamber are equivalent. When the brake pedals are depressed, the air valve makes contact with the control valve, making the constant pressure chamber and variable pressure chamber into 2 independent chambers. When the pedal is depressed further, the air valve moves away from the control valve, allowing air to enter the variable pressure chamber. This difference in pressure is used to push the push rod. When holding the brake, the difference in pressure causes the piston to move to the left. This allows the control valve and the air valve to make contact, preventing further air from coming in. When the brake pedal is depressed fully, the air valve moves away from the control valve again, allowing air to fill the variable chamber. Therefore, even if the pedal is depressed further, the force generated by the difference in pressure will not increase anymore. Only the force pushing the booster pushrod will vary. The tandem-type brake booster is a compact and extremely powerful unit having 2 vacuum chambers. The force enlarged by the pedal's principle of the lever and the difference in pressure of the brake booster is converted to hydraulic pressure in the master cylinder and is transmitted to individual wheels. The substance transmitting the pressure is the brake fluid. If bubbles are generated in this fluid, the pressure will not be transmitted accurately, causing serious conditions such as decreasing the brake efficiency. Vapor lock has occurred. This is a condition where heat, generated by excessive use of the brake fluid, has caused the fluid to exceed its boiling point. It has been found that brake fluid used for a long time tends to absorb moisture and could cause the boiling point to drop.
When brake fluid is leaking, would it seriously affect the braking force?
The brake system is designed to have a divided hydraulic system to cope with situations like this. Even if one circuit fails, the other is still operative. FR and FF vehicles have different piping. The tandem master cylinder operates this divided hydraulic system. We will take an FR vehicle as an example to explain the operating principle of the tandem master cylinder. The tandem master cylinder has a divided cylinder chamber. When brakes are not applied, passages exist between the respective cylinder and the reservoir tank. When the brake pedal is depressed, number 1 piston moves to the left, and the piston cup seals the passage between the cylinder and reservoir tank. At the same time, hydraulic pressure is generated, moving number 2 piston to the left, thus sealing the passage between the cylinder and the reservoir tank, and hydraulic pressure is transmitted from respective cylinders. Now assume that a fluid leak occurs in the rear side of an FR vehicle. Under this circumstance, number 1 piston does not create hydraulic pressure. Nevertheless, the number 1 piston moves to the left, makes contact with number 2 piston and pushes it directly. In this way, hydraulic pressure is created at number 2 piston and the brake force is applied to the front brakes. In the case of a leak in the front side, number 2 piston does not create hydraulic pressure, so it advances until it makes contact with the cylinder wall. When number 1 piston is pushed further under this condition, hydraulic pressure is created in the rear side. When braking, a larger load is generated at the front than at the rear of the vehicle. Therefore, if the vehicle tries to brake the front and rear wheels with equal force, the rear wheels, which are subjected to a smaller load, will lock up early, and the vehicle will become unstable. To prevent this, the brake force applied to the rear wheels must be adjusted. The P-valve is designed to automatically reduce the hydraulic pressure applied to the rear wheel cylinder from the master cylinder in proportion to the pedal force applied to the brakes. Inside, the piston is moved constantly due to the difference in the surface areas of the piston chambers. The dual P-valve would have a pair of P-valves operating side by side. This is usually used in diagonal brake piping of FF vehicles. In the case of hydraulic pressure failure in the front, the rear braking force adjusted by the P-valve would be insufficient. The P and B valve is designed to deactivate the P-valve under such circumstances. If a fluid leak occurs in the front brake circuit, the hydraulic pressure from the master cylinder cannot be transmitted. The force pushing the number 2 piston is lost. As the force pushing number 2 piston from the left side is stronger, it will always be pushed to the right. Accordingly, the hydraulic pressure can transmit the strong braking force directly to the rear wheel cylinder without the operation of the P valve.
Wouldn't the normal P valve be inconvenient when having a payload on the rear, such as in commercial vehicles?
That's right. When the vehicle is loaded, a large load acts on the rear wheels. This necessitates increasing the hydraulic pressure to the rear wheel cylinder. The LSPV is designed to have such regulating functions. Here, the piston of the LSPV is being moved upward by the load-sensing spring. When the load is small, the spring does not make contact with the piston. On the other hand, when the load is large, the spring moves the piston upward. The boosted and adjusted brake force is eventually transmitted to the drum and disc brakes. Motion energy is converted to thermal energy and the vehicle stops. Types of drum brakes depend on shoe installation or number of cylinders. For example, the leading trailing shoe type. 2 leading shoe type. And duo servo shoe type. The hydraulic pressure transmitted to the wheel cylinder forces the shoes apart. The lining installed outside the shoe rubs against the drum revolving with the wheel and produces brake force.
So the clearance between the lining and the drum must be kept constant?
That's right. The clearance must be adjusted periodically. However, some systems do this automatically. When the parking brake is applied, the lever is pulled to the left. If there is excessive brake shoe clearance, the adjuster lever would go over the adjuster screw notch. When the parking brake is released, the adjuster screw rotates and adjusts the brake shoe clearance. In the disc brakes, the rotor disc rotating with the wheels is pressed from both sides by disc pads operated by hydraulic pressure and stops the vehicle using friction. The ABS is a system which controls hydraulic pressure precisely and ensures directional stability even at sudden braking.
Does the disc brake have an automatic clearance adjuster for the clearance between the rotor and the disc?
Yes, it does. In the disc brake, the piston seal is deformed as the piston moves. When the brake pedal is released, the piston seal returns to its original shape, therefore pulling the piston back. In the case of pad wear, the piston movement may exceed the deformation amount of the piston seal. In that case, the piston slides and adjusts to a new position. In this way, the clearance between the disc and the pad is always maintained at specification. The parking brake is used to park the vehicle after stopping using foot brakes. Most parking levers have wires or rods which are connected to the brakes of the rear wheel or propeller shaft and are operated by pulling the lever. In the drum type, the brake shoe is apart by pulling the cable and the drum is locked. The disc type in compact vehicles has a crank pin or a spindle in the caliper, and the piston is moved to push the pads against the disc. These are some examples of the problems observed in the brake system. Here is a lineup of some of the typical problems and troubleshooting for them. Inappropriate brake pedal height or insufficient free play could cause brake drag. Check the height of the pedal. Remove the floor carpet under the pedal and measure the distance between the asphalt sheet and the surface of the pedal. In this case, the pedal must be adjusted. Remove the wire connector from the stoplight switch. Loosen the lock nut of the stoplight switch and turn the switch itself 2 or 3 times to loosen it. Loosen the push rod nut and adjust the pedal height by turning the push rod. Tighten the stoplight switch until the pedal stopper makes contact with the cushion. Then tighten the lock nut. Connect the wire connector to the stoplight switch. Next, check the pedal free play amount. If the engine is running, stop it and depress the pedal several times until the pedal reserve distance, when depressed, becomes constant. This is to reduce the vacuum inside the brake booster. Measure the pedal stroke by depressing the pedal by hand until resistance is felt. Adjust the free play if necessary. Loosen the lock nut of the master cylinder push rod and adjust it by turning it. Tighten the lock nut and measure the free play again. Finally, check the pedal height and the stoplight operation. If there is a problem with the brake booster, it could cause unexpectedly strong or inefficient braking. There are several, although not perfect, ways to inspect the brake booster. First, check air tightness. Stop Stop the engine after running it for 1 or 2 minutes and depress the brake pedal as usual. Check that the pedal reserve distance increases as the number of times the pedal is depressed increases. This indicates that the vacuum inside the brake booster is released every time the pedal is depressed. Then check the operation. Stop the engine and depress the pedal several times until the pedal reserve distance becomes constant. Depress the brake pedal and start the engine. Check if the pedal goes down slightly. This indicates that a vacuum is produced by starting the engine and the brake booster is operating normally. Next, go on to check the air tightness with load. With the engine running, depress the brake pedal with a constant foot pressure. Stop the engine and check that the pedal reserve distance does not change for 30 seconds. This indicates that the vacuum in the constant pressure chamber is maintained. If air is contained in the hydraulic circuits, the pedal feel becomes spongy. All air must be bled from the system whenever there is a possibility of air contained in the hydraulic circuit, or each time after disassembling the hydraulic circuit of the brake system. 2 people should conduct the operation. Use mutually understandable signals and confirm each step of the operation with each other as it progresses. First, bleed air from the master cylinder. Confirm that there is adequate fluid in the reservoir tank. Loosen the brake tube flared nut using the SST. Slowly depress the brake pedal and hold it down. Be sure to operate the pedal slowly. Rapid operation would break the air into smaller bubbles, making it very difficult to remove. Tighten the brake tube flared nut and release the brake pedal. Repeat this 3 or 4 times. Connect the brake tube flared nut using the SST and the operation is completed. Follow the same procedures for the rear. Next, bleed air from the hydraulic circuit. Start from the wheel cylinder farthest from the master cylinder. Release the parking brake. Remove the bleeder plug cap from the bleeder plug. Connect a vinyl tube to the bleeder plug and insert the other end in a container half full of brake fluid. Slowly pump the brake pedal several times. With the pedal depressed, loosen the bleeder plug until fluid starts to run out. Then close the bleeder plug. Repeat this procedure until there are no air bubbles in the fluid. Do this for each wheel. Then check for brake fluid leaks. Install the bleeder caps and the operation is completed. During this operation, never allow dirt or water in the fluid. Handle the brake fluid carefully. Never allow brake fluid to drip or spill onto painted surfaces. If this does occur, wash it off immediately. Furthermore, old fluid should not be reused under any circumstances. Excessive clearance between the brake drum and the lining will reduce braking speed. If too small, the brakes will drag. If different at each wheel, the vehicle could be pulled to one side or fishtail. As explained before, some have automatic brake shoe clearance adjustment functions, but others must be checked periodically. The two leading shoe-type brake shoe clearance procedures are explained here. Remove the shoe adjustment plug from the packing plate. Turn the adjusting nut using the SST until the wheel locks. Turn the other end of the adjusting nut using the SST until the wheel can be turned easily. Refer to the repair manual for the standard number of notches to be backed off. Repeat this procedure for all the other wheels. Install the shoe adjustment hole plug and the operation is completed. Worn-out pads or oil or grease on the lining could cause inefficient braking. If the lining pad sticks, brake grab, squealing, or chattering could result. In the front disc brakes, a pad wear indicator is provided to alert the driver that the pad needs to be replaced. When the pad wears out, the pad wear indicator makes contact with the rotor disc and makes a screeching noise during driving. Check the pad thickness through the cylinder inspection hole and replace pads if not within specification. Remove the two installation bolts and the cylinder from the torque plate. Do not disconnect the brake hose. Suspend the brake hose with a cord so that it will not stretch. Disassemble the anti-squeal shim and pad wear indicator from the removed disc pad. Apply grease to the anti-squeal shim and assemble to a new pad. Install the pad wear indicator plate to the inside of the new pad. Be sure that the arrow on the pad wear indicator plate is pointing in the direction of rotation of the rotor disc. After installing the anti-squeal shim, apply grease on the contact point of the cylinder. Install the cylinder. Draw out a small amount of brake fluid from the reservoir and press the piston with a hammer handle or equivalent to put it into place. Distorted brake shoes, sticking, or oil or grease on the lining could cause brake trouble. The brake shoe must be replaced if necessary. Release the parking brake. And remove the front shoe. First, disconnect the return spring using the SST. Hold the end of the pin and turn the hold-down spring 90 degrees using the SST. Remove the anchor spring and then remove the front shoe. As for the rear shoe, hold the end of the pin and turn the hold-down spring 90 degrees using the SST. The parking brake cable has been removed from the anchor plate. Remove the parking brake cable from the lever using a pair of needle nose pliers and remove the rear shoe along with the strut. Remove the automatic adjustment lever by pulling up the C washer with a screwdriver. Then remove the parking brake lever from the rear brake shoe by pulling up the C washer. Inspect the rear brake parts. First, measure the inside diameter of the brake drum. The brake drum should be replaced if not within specifications. Then make sure there is no abnormal wear or damage. Measure the brake shoe lining thickness. Minimum thickness is 1 millimeter. The brake shoe must be replaced if not within specification or if it is close to minimum tolerance. Check that the brake lining and drum make contact appropriately by applying chalk on the inside of the drum and placing the brake shoe inside. Remove the chalk after inspection. If not making contact properly, repair the lining using a brake shoe grinder or else replace the shoe. Install the rear brake shoe after all necessary inspection has been completed. Apply specified brake grease to the contact point of the packing plate and brake shoe. Anchor plate and brake shoe. Adjustment bolt and the adjuster and brake shoe. Install the parking brake lever temporarily to the rear shoe using a new C washer. Measure the clearance between the brake shoe and the lever using a filler gauge. Replace the shim if not within specification. Assemble the C washer using a pair of pliers. Then install the automatic adjustment lever to the rear shoe. Assemble the new C washer. Confirm that both levers move properly. Then go on to the rear shoe. Connect the parking brake cable to the parking shoe lever using the SST. Assemble the return spring to the rear shoe. Assemble the lever spring to the automatic adjustment lever using the SST. Set one side of the rear shoe into the wheel cylinder and the other to the anchor plate. Assemble the shoe hold-down spring, two retainers, and the pin using the SST. Next, install the front shoe. First, assemble the anchor spring between the front and rear shoe. Follow the same procedures as the rear shoe and set one side of the front shoe to the wheel cylinder and the other to the adjuster. Assemble the shoe hold-down spring, two retainers, and the pin using the SST. Connect the return spring using the SST. After this, clean the brake lining. Be sure to wipe off any oil stains on the brake shoe lining using sandpaper. Also, clean the inside surface of the brake drum. Next, check the automatic adjustment function and the clearance between the shoe and drum. Confirm that the adjustment bolt rotates as the parking lever is being pulled. Check the clearance between the shoe and drum. Release the parking brake. Remove the drum and measure the drum inside diameter. Then measure the brake shoe outside diameter. Confirm that the clearance between them meets the specification of 0.6 millimeters. Adjust the adjuster to its minimum length. Install the brake drum and assemble the hub nut to the hub bolt temporarily. Pull up the parking brake lever until the cracking sound cannot be heard. Finally, check the brake operation. Depress the brake pedal a few times and confirm that both drums rotate smoothly. Confirm that the reserve pedal distance is within specification. Also, confirm there is no brake fluid leak at these points. Install the rear wheel and tighten the hub nut to the specified torque to finish. The following precautions must be kept firmly in mind when overhauling. When a vehicle is brought in for repair, inspect the vehicle carefully to see whether overhauling is really necessary or not. Every time removing a part, be sure to inspect it carefully. Check how the part was assembled originally, whether it has wear or damage. This is important because some of the causes may be here. Keep the disassembled parts in good order. Be sure that the cylinder cup and other rubber parts, inner surface of the drums, linings, pads, friction surface of the rotor disc are free of oil or grease. Before reassembling, clean all parts by washing or with compressed air. Parts must be reassembled accurately according to the specified steps and using the correct tools and SSTs. Check to make sure that parts have been assembled and mounted accurately. Then adjust if necessary to the specified values using the correct gauges and testers. Observe carefully the master cylinder overhauling procedures, keeping the previously mentioned matters in mind. Disconnect the brake tube using the SST. Do not attempt to disconnect or connect the tube with an ordinary wrench, as it will damage the hexagonal nut. Remove the reservoir tank. Next, tape the screwdriver tip. Push the pistons in all the way and remove the stopper bolt and gasket. Inspect the master cylinder bore for scoring or corrosion. Inspect the piston and cups for wear, scoring, cracks, or swelling. If any of these need replacement, use the parts from the cylinder kit. Apply lithium soap-based glycol grease to rubber parts shown here. Assemble the parts to the master cylinder following the reverse procedures. Install the reservoir. The set screw will not tighten down the reservoir, therefore a clearance exists, but do not insert washers when tightening. Adjust the length of the brake booster push rod. This is to create an appropriate clearance between the master cylinder piston and the booster push rod. Set the SST rod so it barely touches the master cylinder piston. Push the booster push rod several times and check that the reaction disc is straight. Set the other end of the SST to the booster without changing the position of the SST rod. Appropriate clearance will be created between the master cylinder and booster if there is no gap between the SST rod and booster push rod. If there is a gap, adjust the booster push rod length. Confirm that the up mark on the master cylinder boot is in correct position. And fill the brake reservoir with brake fluid and bleed air from the brake system. follow the previously explained procedures when bleeding air. Here are the wheel cylinder overhauling procedures. Disassembling the rear drum brake is not so complicated. Inspect the parts. Check for any damage on the piston cup or inside of the cylinder. Next is the assembling procedure. Check the direction and insert the two piston cups in the piston and apply grease. Insert the spring and the two pistons inside the wheel cylinder. Make sure that the piston cup is facing the appropriate side at this time. Assemble the boot. Assemble the wheel cylinder to the backing plate using 2 bolts. When connecting the brake tube, use the SST as shown here. Now, let's go on to the front disc brake wheel cylinder assembling procedures. Remove the union bolt and the 2 gaskets from the brake cylinder. Prepare a container to collect brake fluid and remove the flexible hose. Grasp the sliding pin and remove the fixing bolt and cylinder from the torque plate. Remove the 2 brake pads. Then disassemble the cylinder. Remove the set ring and the cylinder boot using a screwdriver. Put a piece of cloth or equivalent between the piston and the cylinder. Use compressed air to remove the piston from the cylinder. Do not place your fingers in front of the piston when using compressed air. Remove the piston seal using a screwdriver and the disassembling is completed. Observe to make sure there is no damage to the piston or piston cups. When assembling, apply grease to the piston seal, piston, cylinder boot, and install the set ring. A brake malfunction can be extremely dangerous. While of course no defective part is installed in a vehicle, your utmost attention and accurate skills are required, especially when it comes to the disassembling and assembling of brake parts, which are directly related to customer and pedestrian safety. Although only some of the inspection, adjustment, and overhauling procedures could be introduced in this video, we hope that you make further effort to improve your skills to provide your customers with excellent service at all times.